Hey people, notes 2.3 are on factoring sums and differences of perfect cubes. So as an introduction, we want to multiply the following expressions. So I'm going to expand this out. So I'm going to multiply x to x squared, which is x to the power of 3. Then I'm going to multiply x to negative xy. And since it's x times x, we get x squared with a y that tags along. And then we also have x times y squared, which is a positive xy squared. If I do that with the x, I also have to distribute the y through. So y to x squared is x squared y. Doesn't matter what order you write the multiplication in. Negative, or y times negative xy is negative xy squared. And then y times y squared is y to the power of 3. Now, what happens here? This goes away with this. These are like terms. These are also like terms, but they cancel each other out because there's a positive and a negative of each one. And I end up getting x cubed plus y cubed. And if you notice right here, this is a sum of perfect cubes. All right, so let's see what happens in our next expression. If I multiply this x through to this x squared, I get x to the power of 3. X multiplied by xy gives me positive x squared y. X multiplied by y squared is xy squared. Now I'm going to multiply this negative y through, so I get negative x squared y. Negative y to the xy, I get negative xy, and then negative y to y squared gives me negative y cubed. The same thing happens. This x squared y cancels with this negative x squared y. Sorry, this should have said minus xy squared. And then we also know that this xy squared is going to cancel with this negative xy squared. So I end up getting x cubed minus y cubed, which is almost the exact same thing that happened here, except instead of it being a sum of perfect cubes, now we're going to have subtraction, or a difference of perfect cubes. So what does this tell us? This tells us that if I want to factor a sum of perfect cubes, it will look as follows. Because remember, factoring is undoing your multiplication. You're working backwards. You're finding out what times what gives us this expression right here. And then if I wanted to factor x cubed minus y cubed, it would look just like this right here. So what does this mean? If I want to factor a cubed plus b cubed, and I'm using a and b instead of x and y, just because that's typically how it's used, but you can use any variables you want. If I were to factor that out, it will look like a plus b, just like we have right here, x plus y, times a squared minus ab, just like we had minus xy, plus, instead of y squared, it will be b squared. So this right here is the factored form. And the difference of perfect cubes is almost exactly the same. It's a cubed minus b cubed, but instead of a plus b, it will now be a minus b. And then here, instead of a squared minus ab, it is now a squared plus ab plus b squared. And we need one of these to be positive, one of these to be negative, so that these terms that we have here to cancel out. And same thing here, one negative, one positive to get these terms here to cancel out. And this is also our factored form. So how do I apply this? So up here, we have 125y cubed plus 8. So since it's plus, we know it's a sum of perfect cubes. So just a reminder that when I want to factor this, it would become a plus b times a squared minus ab plus b squared. And that's what a cubed plus b cubed is. So I'm literally just copying this down on this page right here so I have it in front of me. So now I have to identify what the a is and what the b is. So if you can see here, the a cubed is this 125y to the power of 3. And the b cubed is this 8. So I'm going to write on the side right here, I want to figure out what a is going to be if I know what a cubed is. So here, if we know that a cubed is 125y to the power of 3, then we can cube root both sides. The opposite of cubing is cube rooting. So I would get a equals, and then right here, The cube root of 125 is 5 because 5 multiplied by itself 3 times gives me 125. And then the cube root of y to the power of 3 is just y. And then I'll do the same thing for the b. We know that b cubed is going to equal 8. So I'm going to say here b cubed equals 8. I'm going to take the cube root of 8, and then I end up getting b equals 2. So what I'm going to do here is I'm going to rewrite this as a cubed plus b cubed. So here I know that my a is going to be 5y. So this is 5y cubed. Isn't that the same thing as 125y to the power of 3? It sure is. So now here I'm also going to do the same thing with the 8. I'm going to do 2 to the power of 3, and that's what gives me 8 right here. So I know my a and my b. Okay, so now if you remember right here, the factored form looks like this. So it is going to be, just move this over here. Sorry, I know you can't do that on your paper. Just try to squeeze it in. So right here, I'm going to write this out as a plus b times a squared minus ab plus b squared. So again, so this would be a plus b multiplied by a squared minus ab plus b squared. Okay, so right here, I know that my a is 5y. So I can say that this is 5y plus, we know that b right here would have to be 2. And then here, I would say that this is 5y squared minus 5y multiplied by 2 plus 2 squared. And now I'm just going to evaluate some of these things here. So I can say that this is just going to be 5y plus 2. There's nothing really to evaluate in my first bracket, but I'm going to figure out what each one of these numbers is. So I'm going to figure out what 5y squared is. And 5y squared means 5y times 5y, which is 25y squared. Here I've got 5y times 2, which is 10y, but because it's a minus sign, we're going to say minus 10y. And then here I'm going to do 2 squared, which is 4. So I'm going to put a 4 right here. And this is my factored form. If I were to distribute this all through here, all of this stuff right here through, I would end up getting this as my answer. So that is my factored form. Okay, so let's take a look at our next example. This time, we've got a minus sign. So we want to do a difference of perfect cubes. So I'm going to just write down the factored form right here. So we know a cubed minus b cubed, I'm just taking it from the previous page, is equal to a minus b times a squared plus ab plus b squared. Okay, so here I know that what I have written here is going to be something cubed minus something cubed. So I want to figure out what that something is. And me showing this workout on the side is just to help you see it, to help you understand what we're doing. You don't have to show the actual cube rooting if you can just figure out what it is. So here I know that a cubed is going to have to be equal to 27a to the power of 6b to the power of 12. So I'm going to take the cube root of everybody inside of here. So I end up getting a equals. The cube root of 27 is 3 because 3 times 3 times 3 is 27. Then I get a to the power of 2 because a to the power of 2 multiplied by itself 3 times gives me a to the power of 6. You can just divide this exponent by this root right here because this is always the denominator of your exponents. And then here I've got b to the power of 12. Just divide that 12 by 3. So we know what a is. We know that this is 3a squared b to the power of 4, and that's being raised to the power of 3. Now let's figure out what the b is. So the b right here is b to the power of 3 is going to be 64c to the power of 15. So here I'm going to say b cubed is equal to 64c to the power of 15. I'm going to cube root both sides to calculate what this is, so I get b equals. The cube root of 64 is 4, because 4 times 4 times 4 is 64, and then I get c to the power of 5, because 15 divided by 3 is 5. So this right here is 4c to the power of 5. So now let's go ahead and get ready to do our factoring piece right here, now that we know what a and b are. So we know it's going to be a minus b multiplied by a squared plus ab, so it's going to be something times something, and then plus b squared. So I'm going to say right here plus that b squared. Okay, so we know that a is going to be, I'm going to zoom in on this a little bit so you can see this a little bit more clearly. We know this is going to be 3a squared b to the power of 4, and that's going to be minus the b, which we know is 4c to the power of 5. And then that's going to get multiplied by whatever you get when you square the a. So this is going to be 3a squared b to the power of 4 squared plus, again, the a is 3a squared b to the power of 4. That's going to get multiplied by b, which we know is 4c to the power of 5, plus 4c to the power of 5 squared. So right here, there's really nothing I can do with this first expression. So I'm going to keep it as is. And then in my second expression, I'm going to actually square this. So 3 when I square it is 9. A squared when I square it is a to the power of 4, and b to the power of 4 when I square it is b to the power of 8. Okay, here I'm going to multiply these two together. So 3 times 4 is 12, and then I just have a squared b to the power of 4, c to the power of 5. And then lastly, I'm just going to square this. So 4 squared is 16. C to the power of 5 when I square it is c to the power of 10. And then this right here is my factored expression. Okay, so really, just to recap, you just have to figure out what a and b are, and then you just plug it in into this piece right here, and then you are good to go. That's it. If you have any questions, let me know. Otherwise, I'll see you in class. Bye.